All right, here we go. Exercise 1, the last exercise of the list chapter. Um, you've made it. Let's knock this one out. So it's asking us to write a program that allows the user to enter a string, and then it prints a table of letters as seen below in alphabetical order. The letters that occur in the string and the number of times they occur in the string. Case should be ignored. For example, if they enter this as a string with upper and lowercase letters, it should return these letters because those are the letters in the string in alphabetical order with the number of times that they appeared. So in a lot of ways, this is similar to our exercise that we did in a previous chapter where we were going through a string and counting up how many times E appears and finding the percentage of letters that are E. This is very similar to that. And so it's gonna be a lot of the same thing. So let's do this. There he asks us to write a program. We don't really need a function that does any of this specific stuff. So I'm just going to define it all in main. So if double under name equals the string double under main, run main. And then we want the user to enter a string, and then we want to iterate through the string. So let's do input. No, we can't do input. Let's do text equals input. And what did they say up here? Please enter a sentence. Okay. Please enter a sentence. Colon space. So that'll get our text. And then we want to iterate through the text. So for letter in text, we want to see, we want to use a dictionary for this. So we're going to be constructing a dictionary as we go through. We're going to, if the, write out comments here. If we've seen the letter already, so if the letter already exists in the dictionary, increase count. So it'll be a lot like the accumulator pattern that we used for that earlier problem. So we're going to accumulate, but instead of accumulating on a single accumulator variable, we're going to accumulate inside of a dictionary. So if we've seen the letter already, we want to increase the count. If we haven't, create an entry for the letter. Okay, so that's what we need to do in this for loop. So because it's much like an accumulator pattern, I need to set up our accumulator variable. In this case, the list that we're going to be using to accumulate, I need to set it up outside of the for loop. That way I have access to it later. So I will call it letter count. And it's going to be equal to an empty dictionary. So how do we check if we've seen the letter already? So if letter in letter count, so if letter exists in letter count, then we want to simply increase the count of that letter. So letter count letter plus equals 1. We just want to increase it by 1. If we haven't seen it, so else create a new entry for the letter. So like we did way down below in problem number 6 down here, where we created new entries for oranges, or in this inventory problem where we created new entries for strawberries if strawberry didn't exist in the list already. We want to do that up here in number 1. We want to do the same thing. We want to, if it hasn't been seen, we want to set letter count letter equal to 1 because we're initializing it with a count of 1 because it's the first time we've seen it. We've seen it once so far, so set it to 1. All right, so that's gonna fill up our letter count dictionary. That's all we need to do to fill up the dictionary. Now we need to print out the dictionary. But we can't just print out the dictionary straight through. We need to print out the key value pairs in alphabetical order. So we can't sort a dictionary. We just simply can't. That's part of the trade-off that we lose when we use a dictionary over the list, is that dictionaries are by definition unsorted in Python. So we cannot sort them. However, because we can grab their keys in a list in the form of dot keys, so in this case, we can grab letter count dot keys. This is going to return a list of the keys, and we can sort list. So if we do sorted keys equals letter count dot keys dot sort, you can chain method calls like this. So letter count dot keys dot sort, and I'm going to call sorted actually, is going to return the sorted keys. So let me save this and run this just in case, see if it errors out. We have bad input on line 1. I forgot my colon. Please enter a sentence. This is a sentence. And we errored out list does not have sorted, so let's try sort. Sorry, I have forgotten my syntax today. This is a sentence. All right, no output, no errors, which means that it should have worked. So sorted keys is now equal to the key list from letter count, but in sorted alphabetical order. Now we can iterate through the keys list in order to grab the associated value. What I mean by that is if we sort through and say for letter in sorted keys, so every letter that we see in the sorted list of keys, if we go to the letter count dictionary and grab that letter, it should return the number of times we've seen it. So we want to print letter plus space plus letter count letter, and because this is a int, we're going to want to print it as a string. So that should just print out each letter and the number of times they appear. So let's run it, see what happens. No errors immediately, that's good. This is a sentence. None type object is not iterable on line 17. Oh, it's because we tried to set this equal to sorted keys, which is sort does not return a value. So I actually can't do this. I need to set sorted keys equal to letter count dot keys and then sort sorted keys, because sorted keys does not return a value. So if that caused you issues, I apologize. Sometimes we have to remember that these list methods do not actually return values. So let me get rid of this and instead comment this with get and sort keys from dictionary, and then iterate through sorted keys and print associated values. All right, so now this should work. Save, run. This is a sentence. All right. So that obviously didn't work. Why didn't that work? Well, I forgot that we are not counting case, so really I should cast the whole thing to lowercase. And also I'm counting spaces and punctuation, which I don't want to do. So that's easy enough. We can just check for if letter is alpha, and then put everything inside of here, inside of that. And also we want to do text equals input and then lower. That should get the lowercase version of the text. Let's see if that works. this is a sentence. All right, there we go. Alphabetical order and the number of times that those appear. Let's test our test case up here. Run that. Let's see, 3115, 3115, 124221, 124221, 245512, 245512. Yep, looks like it works. So there we go. We got the input from the user, passed it to lowercase, and then we set up a dictionary to accumulate our values in. We iterated through the text, and where the letter was and where the actual character was a letter, if we saw it already, we accumulated that number. If we hadn't, we created a new entry for it. We sorted the key list from the dictionary and then iterated through the sorted list to grab the value from the dictionary in alphabetical order. So there we go. That is it. That is the entirety of Chapter 10's exercises. So I know it's a lot more difficult than usual. I think so, at least. We didn't do any exercises with tuples, but your weekly graded assignment is going to rely on your understanding of tuples. Specifically, what you need to know is that tuples can be indexed into. So for example, here we have a series of tuples here. Horny Karen is the dictionary key, and the value stored underneath that dictionary key is a tuple of an phone number and an email address. The phone number would be index 0, and the email address would be index 1. So if I wanted to call this dictionary and that value, what I would want to do is call contacts index Horny Karen index 0 to get the phone number, or contacts index Horny Karen index 1 to get the email number. So tuples can be indexed into. So make sure you understand that as you go and try to do this problem. Again, go back and read the page on tuples. I'm sorry that none of the exercises today utilize tuples. That's unfortunate, but hopefully they shouldn't be too different from what we've seen so far that it makes this problem unsolvable for you. Good luck, guys.